Hello, Neural Network listeners. My name is Vasudevan Lakshmanan, and I'm your podcast co-host. Today, Armand and I discuss with Dr. Liu the impact of his research within artificial intelligence. But before we get into part one of our interview with Dr. Liu, I just have two quick things that I'd like to note. First, a huge shout out to Dr. Liu for providing us with his time to discuss his research. Unlike several other professors and interviews that we've conducted on this podcast, Dr. Liu uniquely combines artificial intelligence and social sciences to create an applicable impact onto everybody in the United States through the amazing research that he's conducting. And the second major shout out is to you, the listeners. Throughout the past few episodes, we've realized that you guys have an interest towards our interviews with professors. Thus, we hope to continue to find different professors to interview to get their unique insight on each topic and their novel research that is taking place. Without further ado, I present to you episode 9, part 1 of our interview with Dr. Liu. Professor Liu, would you like to introduce yourself to the Neural Network podcast listeners?
Sure. So my name is Xiaozhong Liu. I'm a social professor at the WPI, Computer Science and Data Science, and my research is focusing on natural language processing, GPT, like a large language model, AI stuff, graph mining. So that's my area.
Can you tell us more about some of your other projects as well as like go a little bit deeper into your research interests?
Other project, I mean, most of my research is focusing on natural language processing, including information retrieval, and the information retrieval recommendation, and also I have a background in information science, so I have been working with computational social science as well. And for regarding the applications, I've been working for e-commerce and also the biomedical research by using natural language processing and graph mining methodologies. So that's my application side.
Are there any like specific projects that you found particularly groundbreaking or impactful?
Um, I would say they are quite a different. So for instance, I've been working with e-commerce based in e-commerce system. So using different algorithm like AI methodologies to improve the effectiveness and the accuracy of the recommendation system, especially for explainable recommendations. So by using recent method like the large language models, so to enable not just recommend the product, but also with the reasons why you may interest in specific products. So that's something I did. And also I've been working on on the e-commerce system or search different web-based applications to try to help try to protect the young users, like very very young junior users, and for example, detect those pornography information, pornography content, and remove those from the website. So and all the digital library. So that's some of my work regarding e-commerce side. And also I recently worked on drug repurposing project, so which can be pretty exciting. So I designed a new machine learning algorithm to investigate a large number of clinical trial database and also PubMed database. So using large language model to read all the papers, and then serve for the purpose for drug discovery, drug repurposing. So that's another project I've been working on.
Yeah, that's very fantastic. I mean,
Thank you.
I know that currently, especially with all the information going around about big tech and the large court cases that are going on, there's a lot about keeping our kids our age safe on the internet. And I think it's very admirable, the work
Yeah,
that you do.
you're right.
Addi-
Yeah.
yeah, I got it. Additionally to that, could you also elaborate on your journey as a computer scientist and what motivated you to take some of these different routes inside your project research?
I think, I mean, as a professor in data science and AI, I would say my efforts can be a twofer. So the first part, I want to make contributions to some fundamental research in AI, like, for example, develop new NLP models, like improve the accuracy of machine learning, to learn from different type of data. We call that data heterogeneity. So we learn from different type of data. So for example, from image, from website, from the text, from the audios, from the videos. So trying to do something like regarding foundations of machine learning. So that's one side. But the other part is I'm particularly interested in because AI, recent AI, I think the most advanced AI or the most exciting AI project not come from academia, instead come from industry. So I really hope some of my work can be used and reach individual users to help them improve their satisfaction and also to protect their for example, protect their privacy, to make sure that the young users can enjoy the website in a safe way and remove those risk information, those dangerous information from the site. Yeah, so I really hope I can do something to help internet to be a better place, safe place for our users, especially for the next generations. Yeah.
Absolutely. Could you elaborate on how you can use large language models to protect users' privacy?
Yeah, recently we have some projects. So for instance, when we train the large language model, so we want to find in the training data, we want to make sure that users' private information, so, those, for example, their ID information, their home address, their phone number won't show uh, in the training data. So we want to provide masking strategies to remove those sensitive information when we training the data. And also we find when we train, especially for personalization models, we find that the users may sometimes, in given the specific domain, users may need to share information across users, while other information may want to hide, so other users should never access. So when we train the personalized information, so personalized large language models, so the large language model will serve specific users. So we may need to train the model by using community data. So for example, for all the cancer patient,
Yeah.
so who suffer from a very specific kind of gene mutation. So we want to group those users together and train a specific model to serve these users. But we need to make sure that those sensitive information, their, for example, insurance information, their home address information won't be shared across different users. So we're trying to provide the models to meet the different goals. For example, remove all the sensitive information, protect privacy, will maximize the model's trustworthiness. Yeah, so this is what we're doing.
That's really interesting. So for the model's trustworthiness, how exactly can you benchmark how much of a difference like getting all this personally identifiable information has? So how can you like test how ethical or how efficient or how effective it is?
Yeah, regarding the trustworthiness, I can give you two examples. So one example is for like patient. Once again, I use patient. So patient is a very we need to make sure the model be able to provide trustful information for each individual. But when the patient talk to large language models, so everybody have his or her own problem, own scenario, and this scenario may not just happen in one day. So we need to accumulate a lot of history data. So the history data may come in very different form. So some of the form is some of the data like CT scan, some of the data like the notes from the doctor, some of the data like for example the clinical notes. So all of those information will need to be learned by large language models. So the language model should know everything about this individual,
Yep.
and then help the user regarding his or her questions about about every problem. So that's one example. Well, the other example is the model sometimes overconfidence. Model always provide a user a answer, and sometimes the answer is not really trustful. So we want to make sure that all the information delivered by large language models are somehow trustful, or to say that the model should have understand uh, what is the confidence. So we call the calibration model. So we train the model to say, I don't know.
Yeah.
This is very, very important. So when the model, for example, I say, I feel drowsy today. I have a little bit fever. So may I eat a piece of Tylenol, for instance? So if you're a healthy user, so maybe the system large language model can give you some suggestion like how and why you can take Tylenol or not. But if you're a patient with diabetes history or with cancer history, and then the model should hesitate and do not give you suggestion, just say I don't know, or connect you with a professional who can give you professional suggestion, a human being who can help you. So the educated model to say I don't know, not overconfidence, that's a very critical challenge for my research.
Mm-hmm. And how are these calibration models trained?
We will need to we train that with a knowledge graph. So when we give we have a biomedical knowledge graph. So the knowledge graph we have a different kind of data. So we will provide a language model with a different kind of training data regarding the topics on the knowledge graph. And so we will then we have some ground truth data, or we have even some domain expert feedback. So we will tell large language models so what type of question you can answer, what type of question you cannot answer regarding those topics. So which means we will provide a trustworthiness uh, boundaries on the knowledge graph. So when the language model find a challenging question which is not in the scope of the trustworthy boundary, and then the model may have a probability to tell you that I don't know, I cannot help you, but I know maybe another agent can help you. So yeah, this is what we do to train the model. So we have trained the calibration model by joint learning the text data
Mhm.
and the knowledge graph data.
Mm-hmm. And just another question, but do you think these calibration models could be applied on like a larger scale with large language models? Because I know like hallucinations are a big concern, or right now especially with like some models just providing blatantly wrong data
Yeah.
or blatantly wrong responses. So you think these kinds of these calibration models could be applied to applications that are not necessarily like medical, but others as well, other more general ones?
You're right. We do another experiment right now with Pittsburgh University and Harvard University. So this is a we train different kind of model, not just for calibration reason, but also for bias reason. So some large language model pretty we call ideologized. So they provide certain ideologies. So for example, some model may believe that, for example, Trump is great or Trump is super bad. So those models are highly biased, or we call it ideologized. So when those models serve in specific sensitive domain like education and election, so they may have some problem.
Yeah.
So we will train the model to understand. So what type of question is trustful? What type of question are not trustful regarding a black box? We call it black box, pretty large language models. So yeah, this can be really critical. Right now, we're working on the experiment for president election, but soon we will touch other topics. Even we're gonna eventually, I think we're strongly interested in when we see large language model being applied in educations, when they reach young generations, do not have a strong ideology yet. So how can we design algorithms to protect those young users? So which can be really important.
Yeah, I couldn't agree more, especially given all the misinformation that's happening online. By providing important, honest information, we can make more educated decisions of the entire society.
Yeah, you're right. So I
Oh,
find a recent study show, including mine, find that a lot of the existing large language models are pretty ideologized. So these type of models, when they apply in the social applications, they can be very dangerous, I think, for our society. And the thing is, later this year, we're gonna organize a panel in a conference talk about the social risks of large language models. Yeah. So this can be a very critical topic.
yeah, I couldn't agree more. On the note of social topics, what motivated you to explore natural language processing, NLP, text graph mining, and computational social sciences?
Uh, because I think those very once again those I believe those topics are very critical. I think the technologies should not exist alone. So ideology, so the technologies should depend on certain social applications. So for instance, I've been working on social media mining for a very, very long time, and
Yep.
I clearly know that there is a chance that exciting technologies like a recommendation algorithm, like a large language models, like a graph minings can be used to enable or enhance social media services, but also can be used, as weaponize, we call it weaponize certain technologies to uh, maybe attack uh, a group of users or to control, manipulate uh, people's cognitive decisions, so which can be very risky. So that's the reason I believe the social studies should work together along with technologies. So I would say interdisciplinary studies can be really important in this domain. So computer science should not work alone, should work close with people from other domain like social science, like a political science, like a biomedical science. So this is very important.
Yeah, I agree a lot. And that also reminds me of a different thing that I actually touched upon, or rather learned about a couple of weeks ago. It's called echo chambers. And I think that's really a big problem that could be used to benefit, but also, as you mentioned, has a significant harm. So the idea that users will get pushed a certain form of content, which can ultimately close their perspectives towards ulterior perspectives on a matter. So I couldn't agree more that we need to work on making a safe and equal place on the internet.
Yeah, we published a couple of papers regarding the topic, like we call that filter bubble. So
Mhm.
filter bubble is that when you like TikTok, like Twitter, good example. So when you, for example, you like Trump a lot or you hate Trump a lot, so you find that a few months later when you use the system, you find that all the people, I mean, in your network or all the people you follow share the same idea with you. So which will make you, uh, stay in a bubble, gonna probably very, very long time. So this can be very risky for the young generations. Yeah, so that's the reason right now in United States or the other countries, you find that people's, I mean, their ideas pretty polarized. So that's not a good thing. So I think it's something we should do to prevent that happen. So by using the algorithms.
Yep. Because I know confirmation bias is a very big thing in the news right now. The idea that an individual gets promoted their own content and then believes that that's the sole perspective. So by
Yeah,
having this research growing and alongside that more awareness of the problem as a whole, I think we're taking initial steps towards addressing the issue.
yeah, yeah. I believe that's important.
I think like in recommendation engines, how exactly can you address I guess echo chambers?
Uh, I mean, recommendation system is really, I mean, one of the key reasons why we have that problem, why we have bubbles or echoes. So it's like when we recommend, most of the recommendation system right now is based on a type of algorithm called collective filtering. So when we use collective filtering, for example, in YouTube or in TikTok, so all the people's their click history or their watching history going to be used to represent target user. So later we're going to use user similarities to recommend the content. So which means I mean, the recommendation system, their users recommended items highly likely depend on how many similar users click or watch those content. So which will make users really enjoy the same content will group together, they get grouped closer and closer. So they're gonna more like encapsulated in one specific bubble. So it's very hard to step out from the bubbles because everything is based on user similarities. So, user similarities, when we do this kind of calculations, reinforce the chance that you find something similar like your taste. So that's the reason I would say uh, it is really dangerous. And some bad people right now, we find also in our recent study, we find that some people's from interest group. So they use this by using this kind of idea. So they will try to recommend some content that purposely want specific people to reach. So, for example, young people's, if they want you to, for example, either you should support Trump or you should hate Trump. So they can provide some information, not directly to this group of users, but to other users made similar to this group of users, and then they can attack these recommendation systems. Yeah, so this is not acceptable. So we're trying to provide defend mechanism to find such problem.
Oh yeah, it's like a really prominent issue. I didn't even think about the fact that people could like turn these, I guess, these recommendation systems on their head and use them to attack other people.
Yep.
So I guess like how exactly does your project like address that? Like how would you go about working against that?
We find we provided once again the defense system. So we find that for example, either a specific account is very suspicious, so their behavior, this is a kind of like outlier detection algorithm. So if their actions, if they're for example, either sharing actions or posting actions or reply actions, kind of like abnormal. So we will use the algorithm to detect. So those kind of accounts can be outlier, and the algorithm may do something regarding that. So that's one way. Well, the other way is we use large language models. So for example, when we give you a recommendation system, recommend you, for example, say Trump is a superhero. Okay, or Trump is a very bad guy. So we will random sample a number of posts from the other side. So for example, why Trump is maybe not a bad guy, or why Trump maybe is a bad guy. Okay, we will recommend from the other campaign, and we will summarize such content to the user. And so we will let users to know the other side of the story, and we will provide hyperlinks, or everything can be done by large language models automatically. So we'll try to do that to provide a more comprehensive picture to the users. Yeah.
Hi, Neural Network listeners. It's your podcast co-host, Vasudev and Lakshmanin, and I'd just like to thank you for listening to part 1 of our interview with Dr. Liu. Please tune in next week to listen to part 2 of our interview with Dr. Liu, where we'll dive even deeper into the technical details of his research, alongside his impact and the impact that he hopes to have on other students interested in the field. Thank you so much for listening, and we look forward to seeing you next week.